All right. Good afternoon. So my name is Sugu. I'm the co-creator of Vitess and CTO at PlanetScale. And I thought I should talk about something contradictory, stateless storage. But hopefully, I hope that I can defend this title. Hopefully, I can talk about why I call this the way it is. So how many of you have not been to the keynote or do not know what Vitess is? Okay, there are a few. So I'll do a quick rundown of what Vitess is, and then we'll get into what this stateless storage is all about. So Vitess is what I call is a cloud-native database, which means that it runs very comfortably in Kubernetes without losing your data. It scales massively. Actually, that's how it was originally born. When we started developing it in 2010 at YouTube, it was mostly meant to just scale massively. And later, it became cloud-native. Highly available. You can configure Vitess to have almost no downtime or practically no downtime. Something like 5 nines of availability. And it's based on MySQL. Means that it uses MySQL underneath. It also speaks the MySQL protocol. So if you are already on MySQL or if you are familiar with MySQL, migrating Vitess is not a heavy lift. Obviously, Vitess is graduated. I assume many of you know. And here are some of the stats. So more than even the numbers, the thing that we are most proud about in Vitess is who is using Vitess, who adopted Vitess, right? And here's a more extensive list of adopters that I didn't share about in the keynote, which is, so if you ask me, the coolest part of these adopters is these are what I consider technology leaders in the industry. So when these people say that they are using a technology, they are kind of setting the example that a lot of others tend to follow. So it's a pretty good stamp of approval if you look at some of the names here, like Slack, GitHub, New Relic, Pinterest. So these are companies that are looked upon to when you think about how do you scale infrastructure. So, and some quotes from many of these adopters. So Slack basically is saying that there is nothing like Vitess out there. The things that we wanted to do with our storage system, only Vitess could do it. And here's one from Square, which is saying that somehow you can just keep on scaling Vitess and just keep scaling with you. So that is his testimony. And here's another one from Pinterest. It says that the other cool thing about Vitess is that, yes, you can do all this resharding and scaling, but you don't really have to rewrite your app to be able to achieve the scale. Okay? So those are some of the things that I collected. There's actually lots and lots of quotes that we can collect, but these are some highlights that I collected by looking around. So that is all overview about Vitess. Now I'm going to jump into what makes Vitess cloud native and what this stateless storage means at all. So for that, there's two reasons. There's a historical reason why Vitess is cloud native, and there's also a technical reason. So I'm going to talk about the historical reason and weave the technical details into the story. So it all starts in 2010. We were at YouTube. In 2010, we were on-prem. We had our own data centers. Even though we were acquired by Google, we were not part of Google infrastructure. And at that time, our infrastructure was awesome, was perfect, flawless. Everything was fine. It was not. It was like hell was breaking loose. Things were falling all over the place. And my colleague Mike and I decided to pretty much take ourselves out of this firefighting mode and figure out what we need to do about this thing, because it was not going in the right direction. It was just getting worse by the day. So we actually built a huge spreadsheet of all the problems we have ever seen at YouTube and all the problems we are possibly going to face, and then possible solutions. It's a good exercise, right? Like that gives good clarity. And when you looked at all that, it was obvious we had to build something separate that comes between the application and the database. So we call it a proxy layer, whatever. So that's what we initially built. And from that, Vitess was born. And it was originally called Voltron, by the way, because it was different pieces coming together. But later, I know you can't use Voltron as a project name, which is why. And we used Voltron, and we named all our files VT, 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 right? So you had to come up with a name that's not Voltron that had VT in it. So that's how Vitess was born. Oh, and the other part of the story is, I don't know how many of you have heard of Strongbad. Yeah. So he has a thing where it says that the best way to create a cool name is to actually find a normal name and completely misspell it. I don't know if you know the limousine video. So we said, okay, Vitesse means speed in French, so we're going to drop the E, and then that's why the name is the way it is. So it was all fine, but in 2013, I don't know, you remember the significance of this year, Snowden happened, and there was a directive that no data shall be outside Google data centers. So we had to migrate into Google. And until then, none of us at YouTube knew anything about Google infrastructure. We knew this Borg thing existed, and it did magical things and stuff. But we actually went and looked inside it. It had nothing that we could have used or needed for running Vitess. So Google's Borg is mostly an environment that lets you deploy stateless applications at humongous scale. And if you wanted storage, it gave you APIs. Like there's an API for Bigtable. There's an API for Colossus. There's an API for Megastore. So all the storage, the SS tables, they had a bunch of storages. And by the way, there is no block storage at Google. There is no API for storing something in a file. It doesn't exist. It's not allowed. And Colossus is the only one, and it's not a file API. That was very intentional design. So we look at all that, and he says, how do you run MySQL on that, right? And the only other storage was you could write to your local disk if you're running as an application, but as soon as your pod gets rescheduled, we will wipe your disk. So that was the deal. So that's one limitation. And the other problem is moving Vitess into Google's ecosystem. They have all these custom APIs. They have Chubby, they have Stubby, they have Borgmon, they have log infrastructure, they have throttling infrastructure. What do all these things have? They all have APIs. So Vitess is an open source project meant to run in bare metal. How do you port this into Google? So the immediate answer was, oh, you should close source it. There is no way you can run this in Google as is, because Google's API is too custom. So we kind of took that as a challenge. We are not going to do that. We are going to see what we can do to keep Vitess open source. So what we did was just build abstraction layer after abstraction layer. And I will come back to what that means, what that meant later in the future. So we built an abstraction layer for Stubby. We built an abstraction layer for Chubby. So we did all that and managed to get something deployed. But what about storage, right? There is no storage API of Google that we could use. So what we did was we just used local storage. But I don't know how many of you were in the previous talk. Jiten actually explained the entire thing in like 2 minutes, but I'm going to take longer to explain what we did. So we ran MySQL in this semi-synchronous mode, which means that we had one master and lots of replicas. I mean, YouTube requires huge amount of read traffic, so we had like 80 to 100 replicas. The semi-sync mode allows you to guarantee that a commit is not complete until at least one other replica had the data. So what that means is that if a master goes down, it's guaranteed that another replica had it. So we relied on that, and we said that, okay, if that happens, which means that it is okay if Borg wipes the data of the master, because there is always one other replica that has it. So that is essentially how we ran Vitess on Borg. So basically, we ran Vitess As far as Borg was concerned, Vitess was a stateless application. So what do you call a stateless application that runs as storage? I call it stateless storage. It's a better name than serverless, right? All right, okay. So guess what? 2015, Kubernetes gets announced. We didn't even know all this was happening. And then we look at Kubernetes. It says, what? Kubernetes has ephemeral storage. It does everything. Isn't that what we've been doing on Borg? So we go talk to the Kubernetes team. They say, hey, we think Vitess can run in Kubernetes already. He says, yeah, it looks like it can. So let's announce it. So we announced before Kubernetes 1.0 was released that Vitess is ready for Kubernetes. So March 20th is the date we blogged. July 21 is when Kubernetes 1.0 was announced. So funny story, people believed us. And they said, so Stitch Labs was the first company that came and said, okay, you think it can work? I say, yeah, totally. So they went into production. Touch wood, they are still in production. So they are the oldest living Vitess instance. They've been running in Kubernetes since 2016. So then came HubSpot. So Stitch Labs was actually a sharded environment. They were previously on ScaleArk, which went out of business. So they said, oh, Vitess can do what ScaleArk does, so therefore we migrate to Vitess. So HubSpot was the first company that actually used Vitess because it ran well on Kubernetes. They said, oh, you have all this orchestration layer, you know how to survive all these pod takedowns, I think we like it. And the cool thing they did was they gathered like 10 terabytes of queries, and they dumped it on Vitess. And a whole bunch of them didn't work. They worked through each and every one of those and got all of them working. So they actually narrowed the gap of the query set that Vitess could handle to, they pushed it pretty far. It's still not completely out there, but a large chunk of the queries that work in Vitess that should work in MySQL, HubSpot actually got it working. And then after a while, some Chinese people started showing up in the Vitess Slack. They never identified themselves, but they were asking extremely sharp and intelligent questions. Like, who are these people? They're asking about query plans. They're asking about like optimization here and there. And then after a long time, they reveal, oh, we are from JD.com. It's the, at that time, it was the second largest online retailer in China. Now it looks like they are the largest now. So, and this 35 million QPS information, I found out only last week. I had to really prod them. You had your singles day. Like, can you give me some good number? And finally, he told me 30. I didn't believe it. No way. Say, should I just say like a few, like JD does just a few million QPS? Say, oh, no. This comes straight out of our graphs. You can take it to the bank. Say, okay, I'm going to announce it in the keynote. So that's the story behind JD. And finally, all of you know about Nozzle, where they were the first ones to prove that you can actually move from cloud to cloud if you are fully on Kubernetes and running on Vitess. The one part that I was not clear about is how they actually did the pipeline. And probably Thursday when Derek talks about it, I'm sure he'll cover how he did that. So Vitess has been running for 3 years, right? The thing is that we did not know that Kubernetes, you are not supposed to run storage on Kubernetes. This is all like our own recommendations based on the fact that we ran on Borg and that we know how to run this on Kubernetes, right? So Kelsey comes up and says, oh, don't put storage on Kubernetes, it's big danger. I'm like, Kelsey, we've been doing this for 3 years now. But he has a point. This is his point. It says, you cannot just take MySQL and put it in Kubernetes. You will lose your data. You're guaranteed to lose your data. Or you are going to have other problems, probably bigger than losing your data. So I'm going to go through some of the scenarios, some of the details involved in why he's giving this advice. His advice is sound, and there is a reason for it. So here's the thing, right? I'm the naive person. I'm going to say, okay, I'm going to take MySQL and put it in a pod and use local storage. Boom, right? The first thing is what happens when your pod gets rescheduled. It's going to wipe all your data. So obviously, nobody should be running it this way. This is probably a more sane deployment where you say, okay, I'll have mounted volume and then use PD or EBS, whatever, and just run MySQL as a stateless application. This will work and this can work. There are some people who use this configuration. The problem here is if your pod gets rescheduled, MySQL, when it comes back up, has to perform crash recovery, and that can take a long time. I don't know, minutes, hours sometimes, depending on how big your data is. So it's definitely not good for high uptime. So if you don't care about uptime, yes, you can configure it this way. But there is a problem. MySQL is tuned for low latency IOPS. And going through a network boundary is not something it enjoys. So you're going to pay some price on throughput. Strangely, not many people care about it. There are people who can tolerate this, and those who can tolerate it, it's fine. The people who cannot tolerate this are typically people who are already on-prem, already used to this latency, and their app has been tuned to that latency. And suddenly, if you increase the latency between the MySQL and disk, it's something that most apps don't tolerate. So we had that problem at YouTube. YouTube, every millisecond counted. And so you couldn't put a network between the database and its disk. So here's another scenario, right? So how do you put multiple? So the other scenario is to say I'll do the master replica scenario, right, where I have one master and one replica, and each in their own pods. You could do this either with local storage or with mounted storage, but the problems are similar. So let's say you are going to deploy a stateful set, right? Stateful set was created for stateful things. That's a lie. Stateful state has no state. Do you know that? The only state in stateful set is outside of stateful sets. So the only way a stateful set, the main property of a stateful set is that you can identify each pod individually and give it a specific traffic. So that is the property of a stateful set. So you can say pod 0 is my master and pod 1 is my replica. And you can ask the app server, talk to pod 0 because it is the master. Right? So we can make that happen. You cannot use Kubernetes' automatic load balancing because Kubernetes will not differentiate between a master and replica. So you have to talk to individual pods. So the main problem is you cannot designate the master if you address the stateful set as an entire entity, which means that you have to address each pod. But if a pod gets rescheduled, and I say, okay, I'm going to fail over my master to pod 1 as replica, you have to tell the app. And that doesn't happen automatically for you. You have to write some code, some orchestration tool that tells the app. Either you have to do a DNS update or you have to do some config push, something you have to write. Just taking MySQL and putting it in this configuration is not going to work for you. So how does this work on-prem? On-prem masters don't go down. The uptime for masters is like 2 months, 3 months, 6 months. Here, they go down like once a week, at least. Probably more often, depending on how much entropy there exists around here. Kubernetes may want to shift things around. So those are the 3 problems with using MySQL in this scenario. And if you bring up a new replica, how do you initialize it? That's another problem. It cannot, in Kubernetes, just bringing up MySQL, how do you initialize the data saying that, okay, the data from the master has to be copied, it has to be pointed to that master. So all that orchestration is something that you have to write extra. So which is the reason why Kelsey has been saying that you cannot just take MySQL things that are storage that is supposed to run on-prem directly into Kubernetes. There's a lot of glue code that needs to be written, which is essentially what Vitess does for you, which is what we had to do for ourselves. Okay. All right, and then there are cultural issues. And trust me, these are actually really, really horrible, because if you have configured your system with these long-running instances, taking it to a cloud environment is extremely different. Like the life cycle, like you expect things to change at certain rate, but in the cloud, they change at a different rate. Like how long does a process live? The data size. So Kubernetes likes smaller data size. In on-prem, you may have a 14 terabyte database. And Kubernetes likes to move things around. You cannot move terabytes around with such ease. So the culture of Vitess is to build smaller chunks. And so those we can quickly move around, even if Kubernetes reschedules you. Kubernetes likes to reuse IPs. That's a no-no in on-prem. IPs are fixed for life, and and topology overload is another big concern. Many people think that systems like etcd, Zookeeper can be used like a regular data store. No, they are supposed to be used extremely sparingly. And when you scale things out, you accidentally spam your topo and bring it down. So all these things we had to change in Vitess. So it's not very easy to convert a non-cloud ready software to be cloud ready, because it is not sensitive to these cultural differences that exist between the two, and you may end up spamming things that you should not be spamming. All right, so far so good. Okay, good, doing on time. So Kelsey did later reiterate his statement, and he says, yes, you cannot, but you can use systems like Vitess, because they actually provide the glue between Kubernetes and the storage. So here is the Vitess architecture. The app server, as far as the app server is concerned, so essentially if you look at all the problems in the back, the proxy layer that we introduced at YouTube for solving a different problem is also coming in handy, because that is essentially you cannot run a storage system without a proxy layer, because all those problems can only be solved with the proxy layers standing in the middle. So we had this VT gate. So app server talks to VT gate. VT gate is completely stateless. You can scale it up and down depending on your growing needs. And as far as the app is concerned, once it's connected to a VT gate, it thinks that it is connected to a humongous database. But under the covers, it's actually a whole bunch of MySQLs all working in their own tandem. Like the way I would describe the philosophy behind this architecture is, one is simplicity. We don't have any moving parts that are not necessary. They are the bare minimum of what we need. Loose coupling. So the advantage of loose coupling is indefinite scalability. So that's the reason why Vitess can scale. All these parts are meant to operate on their own with very little interdependency between them. And somebody was saying loose coupling is actually one of the hardest problems to solve in computer science, because things tend to want to come together. And how do you draw the correct boundaries and keep the responsibility separate is where Vitess's innovation lies. And the last but not the least is what I would call survivability, which means that no single component here is essential at a given point of time. So anytime we expect to lose components here, and as they lose, every other part of the system knows how to handle the fact that that component went away. So those are the three principles on which this architecture was built. And I'm going to go through the scenarios that I talked about in the previous slides about the problems that existed and how they get addressed in Vitess. Right? For example, working backwards, when I bring up a new VT tablet as a new replica, so what Vitess will do is it'll say, oh, this VT tablet, my identity is I am key space KS shard 0. Let me go see if there is a backup. So which means that there exists a way for you to perform a backup. So you could go to a VT tablet and say, please do a backup of this, and VT tablet will perform the backup and store the identity and necessary positions needed inside the backup. When the new VT tablet comes up, it'll find that backup and restore it. So it has a starting point. And then it'll point itself to the master and says, based on the bin logs, give me all the events that have taken place, and it will catch up. As soon as it is caught up, what it does is it advertises to the topology, saying that, hey, I am ready to serve traffic. And who is watching the topology? The VT gates. And they discover that, oh, there's a new VT tablet here. I'm going to start sending traffic to this VT tablet. So discovery is handled by this fact. And what is initialization is handled. What other topic did we talk about? Reparenting. So reparenting is the next story. Like, what if a master crashes? Right? If a master, the one thing that we found out is in our original design, I talked about cultural changes, right? In our original design, when a master went down, we said, oh, all you have to do is save it in the topology, and the VT gates will all get it. You know? But topologies are not meant to react that fast. They can, you can be like 15 minutes down, even in Google. The SLA is like 15 minutes before you can get an update from a topology change. You can't go 15 minutes without serving traffic, right? Master went down, I need to react quickly. So what did we do is every VT gate that's connected to VT tablet has a back channel where the VT tablets are continuously feeding health information, both about how healthy they are and also about who is the master. So if a reparent happens, as soon as the VT tablet realizes that it's a master, it'll tell the VT gate, I'm the master now. And we had a situation where sometimes network partition, right? There's a network partition, the old VT tablet says, no, I'm the master. No? There's two people claiming they are the master. So this is where Paxos comes to our help, where we say, what's your master timestamp? What's your master timestamp? I'm going to trust you because you have a newer timestamp. So that way, the system disambiguates and safely continues forward. So that's the reparenting story. So finally, as far as storage is concerned, okay, I'm good in time. So as far as storage is concerned, you can run Vitess both using mounted volume or local storage. So people don't trust Kubernetes enough. They still fear that there may be this black swan incident where the entire Kubernetes crashes. So they still have that fear. So they still have the fear that they may lose all the nodes at the same time. So because of that, most people that run Vitess still put their storage outside. They use mounted volumes because they trust the mounted volumes more. Of course, that trust was recently broken by certain cloud providers. I'm not going to go into that, but at the end of the day, it is software that is running both, whether it's outside or inside. So you can run Vitess with a mounted volume. As a matter of fact, it's better to run a mounted volume using Vitess because you are so widely sharded that your latency sensitivity comes down. Whereas if you just you have a single monolithic MySQL instance, there the latency becomes even more significant. So, and in that case, many of these stories happen. But the case where there is a way to run Vitess, which is how we ran it at YouTube, where we just put it on ephemeral storage, local storage, and semi-sync, like I explained before, and just play the game of survival through numbers. You know, there is no way Borg is going to bring down all my 20 replicas at the same time. So in that case, then there is no need to consider data as sacred. You can say data is disposable because I can rebuild it. And because the shards are small, 200, 300 gigs shards, as soon as a pod goes down, I can rebuild it in like 10 minutes. So which means that my exposure to catastrophic events is highly reduced. And there is one more point I wanted to make about this. Yes, so it's possible that this was covered in the Slack talk. So what is the advantage of treating your local data as ephemeral? The advantage is that you're not going to do crash recovery. We have already made that decision. So we can run MySQL. Ooh, okay. So we can run MySQL in crash unsafe mode because we are never going to recover. So why make it crash safe? So crash unsafe mode means that you can use buffered I/O. So turn off all crash safety. And with buffered I/O, every commit is in-memory operation. So it's now going to scream faster than even a on-prem MySQL. And we had those kinds of numbers when we were running at YouTube. Like we had brought the latency down to like really, really tiny numbers. Like MySQL would react in like microseconds, which is like just memory, right? And VT tablet was on the same machine, local Unix socket, issue a command, instantly get back. So it was like screaming fast. This is a subliminal message. Nobody saw that message. All right, so I'm finished with my talk. Do go to vitess.io. There is a nice tutorial there. Join the Vitess Slack and try bringing up a cluster. You can also go to console.planetscale.com if you are lazy about bringing up your own Vitess cluster. So I am now open to questions. There's a question there. Good question. The question is, if you have multiple shards, how do you take point-in-time consistent backup? The simple answer is we don't. We don't ever need to. Because every shard is on its own. It survives on its own. So different shards get backups taken at different points of time. And the only time we use the backup is to actually start a new VT tablet, right? So it just picks up the snapshot as of whatever time it found it, points it to the master, and it catches up. But there is a use case where you would want something like point in time. It's called when software engineers fat finger things and accidentally wipe up an entire column. Never happened before? So at that time, you want to go back to your old data to restore it. So actually, Deepthi, who's going to be talking tomorrow, has done a feature where she implemented a point-in-time recovery, where you say, I want to create a snapshot of this key space. This is my cutoff time. Even though the backups were taken at different points in time, they are approximately at the same time. Right? And that is usually sufficient for recovery. So on top of this, we are going to add a feature where it will actually fast forward up to the time that you wanted the snapshot to be to happen. So that part we have not done yet, but you can actually restore a key space as of an approximate point in time. Was I accurate? Yes. Okay. Cool. Yes. Do you have use case where we have multi-region deployments? Absolutely. That was what Vitess was built for. In YouTube, there are tens of regions. Pretty much spans YouTube's data centers plan. Vitess deployment spans the entire planet. Yes. Yes, would you consider adding relational databases? Absolutely. We are very, very seriously thinking about Postgres. There has been many people who've been asking about it. We currently have our hands full, but at some point, there will come a time when we are going to have spare engineering bandwidth, and we will definitely look at that. Yes. The question is, where do you start the backups? Where do they store the backups? Where the backups can be stored. Oh, that's the other. That's one of the things that I forgot to cover, which is when we moved into Borg and had to build all these abstraction layers. We built an abstraction layer, for example, for the topo server, which means that we support Zookeeper, we support console, we support etcd. So that we got for free because we had to build that abstraction layer. In the same way, for backups, we built some abstraction layers, which means that you can back it up to a mounted file system, or you can back it up to S3. There's one more storage. Google Cloud Storage is the other one. And also, there's different backup methods. There's the regular backup method, which is stop MySQL and run it. And there's the extra backup, which can actually do the backup while the server is continuing to serve queries. Yes? That's a very good question. So you are saying that with semi-sync replication, only one other replica is guaranteed to have up-to-date data. And how do you make sure that you don't lose any data in terms of, even if you have 80 replicas, the transaction that has committed just now is possibly there only in one other replica. So this goes back to Google's philosophy, which is typically Google says this. So this has worked well in Borg. Google says that things will fail all the time, but the likelihood of two things exactly failing at the same time, even at Google scale, is extremely low. So at YouTube, we never lost data due to this. And in Kubernetes, I don't know if anybody has had the confidence to run in ephemeral mode. But if they do, so I would encourage, I would not encourage somebody to run it in ephemeral mode if you had only 2 replicas. But if you had more than n replicas, like 5 or above, I would feel fairly confident to say that you can run it in ephemeral mode. And at the end of the day, it is always a trade-off that you have to make between complete safety versus performance. You cannot get both. It is the reality of life. And in YouTube, we said that if we lost an entire data center, we are okay giving up the last few transactions that went. So that was our trade-off thing, and everybody was okay with that. It just happened that it has never happened. Losing an entire data center, Google actually has the freedom to come and take down a full data center, but you have notice. So we get notice, and then we fail over to another cell. And eventually, they call these PCRs. They come in and take our entire cell. But during my N years at YouTube, an entire cell never went down without expectation. Yes? Right, yes. So that's an excellent question. Can you run Vitess in hybrid mode? I've been seriously thinking about that, where you run ephemeral everywhere, but have one replica that is writing to a mounted volume. So that's completely viable. You need a slightly more complicated scripts to manage that, but I think it's an excellent idea. Yeah. Yes. Oh, yes, sorry. Because I wanted to cover the cloud aspect, I skipped the rest of the parts. So the way this works is the topology has information about key spaces and shards. And these VT tablets register themselves, and VT gates eventually discover them and send traffic to them. The topology can be, as I said, etcd, Zookeeper, or console. VTCTLD is basically your dashboard. It reads the topology and displays what's in there for you to browse. Eventually, you can discover all the VT tablets that exist and all the VT, not the VT gates, and I can explain why the VT gates are not part of the topology. And you can also initiate workflows. You can go tell VTCTLD, I want to do a resharding, I want to create new shards, I want to split these two things. You can through VTCTLD, you can say create a backup. So all those commands happen through VTCTLD. There are a few more components like VT Worker and stuff. They essentially are mini VTCTLDs that perform very specific tasks. So that's what this architecture is about. And the only reason VT tablet exists is for housekeeping. Like it does the backup, restore, and those things. That is its main purpose. Question here? Does Vitess have the ability to migrate entire data through teardown of an existing cluster? As in, is this an external data type or internal? Is it like a separate MySQL instance, or is it itself? Oh, within itself, it has the concept of cells, and all cells are keeping up with the master, wherever the master is. You can fail over a master from one cell to another and completely tear down that cell. And that happens all the time at YouTube. We take down cells. Sometimes we decommission them. We don't want them anymore, and then bring up new cells. So that happens all the time, and Vitess is built to handle those workflows. Yes? Pardon? Oh, how do you do multiple cloud? Query across multiple shards. So that is a challenge. That is, I would say, the curse of a sharded system. The curse of a sharded system is that when you make a decision to say that data A lives here and data B lives there, that means that if you have to join the two, you are going to go across shards. So Vitess will do a best effort of saying that if you're going to join table A with table B and the rows are not together, it will actually do the back and forth for you and still give you the results. It will not perform as well. But what you can do is there is a new feature of Vitess that is called vReplication, where you can say, even though this data is here and even though that data is there, I want this data to be here because it is related to stuff here, but I want the data to be there also because it is related to stuff there. You can say materialize this table from here to there and keep it up to date real time. You just give it a select query and say, do this, and Vitess will materialize that entire table here. And what it will do is it works just like replication. It subscribes to the bin logs and watches the events that are coming and immediately updates the target table. So you can do that for filtering. You can do that for resharding. You can do that for aggregations. You can actually do real-time roll-ups. And it's extremely efficient at keeping the target table up to date. If you have a network partition, you may incur some delays. But if your network is healthy and fine, this table should keep up within milliseconds of the source. I saw a hand. Oh, yes. So the first question is, is there any recommendation on the number of shards? No, the recommendation is about your shard size. So typically we say about 200 to 300 gigs is the shard size, and depending on how big your data is, you have as many shards as you need. People have, the largest instances that I've heard of have hundreds of shards, and Vitess has served comfortably. There are a few people who are going into the thousands of shards range. We'll see how that goes. But I don't know of any architectural limitation that will cause Vitess to struggle if there are too many shards. I think Rafael fixed one bug in one place about parallelism, about single shard. So if there's any issues, there will be minor fixes that we can probably make. Your second question, I didn't get. Oh, correct. The question is, are there any operational concerns? No, the number of shards doesn't cause any operational overheads, is because the effective resource used is the same. Amount of resource used is the same. There is very little static cost added by the fact of the existence of these components. This is because MySQL is capable of scaling itself down really, really well. The place where we found where the static cost of MySQL was beginning to show up was when your data size was below 70 gigs. So money-wise. Money-wise, some people have complained that Vitess does burn a little more CPU than usual. We have identified the root cause as gRPC, and we have to figure out what in gRPC is causing that burn. So we'll get to the bottom of it very soon, but it's only been a very minor complaint. Nobody has complained like, oh, this is a showstopper, I can't go with this level of CPU. So we haven't seen that, but people have groaned about it, saying that, could you? Yes. any kind of, any bad example of workloads. So I would say, we are 15 minutes over. So, all right, so I will get out and then you can ask me questions.